of physics of lasers. And in the last lecture, actually, we started chapter number 5, and we went up to the 3 and 4 level laser systems. Now, in this lecture, what we are going to study, the major 3-level laser is a ruby laser. So, ruby laser is considered as 3-level laser, as you can see in the diagram here, and here, and this is a 3-level lasing system. That this is ULL, upper lasing level, this is ground level, okay, and this is a pump level here. So if you compare this one with the ruby, so it has the absorption band is pretty much wide, and it can be pumped with green light, it can be pumped with violet, so that is why flash lamp is preferred. So I mean the white light, the flash lamp, it covers this region. So it's excited and then it's decay, and decay to ULL, upper lasing level. Okay, this is fast internal relaxation, and the heat is generated here in this decay, and from ULL it decays to the ground, and it emits the laser. Thing is that, as I mentioned in my last lecture, there's ULL, upper lasing level. At this level, the electrons stay. The population inversion is achieved. Okay, this is the main, one of the main condition for the lasing. Okay, so ULL, it stays there, and then after that it decays to the ground and it emits the photons, that is the coherent photons, and this specifically in case of ruby laser, the wavelength is 694 nanometers. So absorption band here, it can be pumped with the green light, it can be pumped with the violet light. So some of the point which is mentioned here, you can see as well that upper lasing level, this one is upper lasing level, it has about 1.8 electron volt above ground from here to here, and the thermal population of this level is 300K. Okay, so this is not very much high. As I mentioned in my last lecture, that in case of a 3-level laser, you need to pump hard, okay, because there is no intermediate level here, so the atoms and it directly decays to the ground. Okay, so it needs much energy to pump and then to achieve the population inversion. Okay, so it has 2 pump bands, as I mentioned. Okay, and strong pumping is required, as I mentioned now. Okay, some few points here which is mentioned, that after pumping, one must wait until significant population of atom reaches the upper lasing level. Okay, that's population inversion. And ruby laser, as you know, this is the first solid state laser actually demonstrated by Mayman, and you can say it's the first experimental demonstration of the laser. And first time the ruby laser is pumped with the flash lamp, which is xenon flash lamp. So in the xenon, this portion green and the violet is readily available, so that is why it's a very good source for pumping the ruby. So other thing which is mentioned here, the pump bands have incredibly short lifetime, order of 1 millisecond. These pump bands, the lifetime is 1 millisecond. Okay, so which causes the energy absorbed in these pump bands. Okay, and it relaxes immediately and it moves towards the ULL, upper lacing level. So the lifetime of this level is 3 millisecond. 3 millisecond is greater than the pump band, lifetime of the pump band. Okay, it's quite long. So this is one of the reasons that allowing the excited ions to remain there long enough to have good chance of emitting light. So stay there, achieve population inversion, okay, and then causes the stimulated emission. As I mentioned in my last lecture, and that 3-level lasers are mostly pulsed lasers. The reason you need to pump hard, you need to have a certain cooling system for this kind of thing. But if they're in case of 4-level laser, you don't need to pump very hard, okay, because atoms they decay from ULL2, not directly to the ground but other. तो इस स्लाइड में मैंने रूबी के बारे में एक्सप्लेन किया है कि रूबी 3-level लेजर है और इसके पंप बैंड जो है वो एक ग्रीन और वायलेट है. So इसे ब्रॉड पंप बैंड है और इसको जीनॉन फ्लैश लैम्प से हम जब पंप करते हैं तो ये रीजन जो है उसमें इजीली कवर हो जाती है. तो पंप जब होता है फिर पंप थोड़ी देर के बाद वो डिके कर जाते हैं यूएलएल पे और यूएलएल से फिर ग्राउंड की तरफ. और जो लाइफ टाइम है पंप बैंड्स का इट्स वेरी शॉर्ट, लाइक 1 millisecond here it's mentioned. और इसका जो लाइफ टाइम है यूएलएल का इज 3 millisecond. So the ions stay there for a while and then population inversion is achieved and then वो जो है वो नीचे ग्राउंड पे आ जाते हैं और हमारे पास लेजिंग एमिट होती है. इसकी वेवलेंथ है 694 नैनोमीटर. दिस इज टिपिकल रूबी लेजर वेवलेंथ. इस रेडिश, ओके, एंड ये जो रूबी लेजर है जैसे मैंने पहले भी बताया है, रूबी लेजर फर्स्ट रूबी लेजर जो डेमोस्ट्रेट की गई थी, एक्चुअली वो पहली लेजर ही डेमोस्ट्रेट की गई थी और ये डेमोस्ट्रेट की थी मेमैन ने. नाउ वी मूव टू द नेक्स्ट स्लाइड. Next slide, what we see is 4-level laser system. So YAG is one of the example of the 4-level laser system. This is a 4-level laser, pump level, ULL, upper lasing level, LL, lower lasing level, okay, and then ground. So it's excited and then from pump to ULL and ULL to LL and LL to ground. What you see here in case of YAG, the pump bands here, 780 to 810 nanometer, that is IR region, okay, 730 to 750, this is also IR region, 525 to 585, so that is green region, green and yellow and etc. like this. So majorly what we use actually the flash lamp, mostly we use the flash lamp to pump the YAG and it covers this portion very easily, the Krypton flash lamp, as I mentioned in my previous lecture. So the thing is here, it has a ULL, okay, and you can also say there are many pump levels. It's a cluster of pump levels here, okay, and from here the atom decays rapidly and decays to the ULL where they stay to achieve the population inversion, and then it moves toward the LL, lower lasing level. There are a number of possibilities. The emission wavelength, but mostly the most common and most easily achievable is 1064 nanometer. There are some of the point which is mentioned here and I also explained somehow. So there are multiple pump levels here, you can see. So it can absorb a variety of wavelengths. Okay, that is why white light flash lamp is a very good source to pump the YAG laser. Even though it can be pumped with other laser like diode laser, who is emitting the emission in this region. And the important band is this one, 790 to 810 nanometer. Okay, useful for pumping. And semiconductor laser, as I mentioned, the semiconductor laser can also be used to pump the YAG laser, whose emission will be in this range. So all the pump levels have a short lifetime. Okay, so atom immediately decay to the ULL. So here the pump level, they have their lifetime is around 100 nanosecond. Okay, and decay rapidly to the ULL. And ULL here, it's having a longer lifetime, that is 1.2 millisecond, 1.2 millisecond here. So 1.2 millisecond, it means the atom decays and it stays here, and to achieve the population inversion, then it emit the laser radiation and it goes to LL. Okay, and as I mentioned, the lifetime of the UL is 1.2 milliseconds. Okay, which is definitely is also greater than the LLL. And from LLL, it decays to the ground in 30 nanosecond rapid. So first ULL and then LL, and then it goes to the ground. So as I mentioned, many laser many lasing transitions are possible in this system, but the most feasible and most powerful one is 1064. Other one like 946 nanometer. In case of 946 nanometer, the YAG laser is considered to be a 3-level laser. So you need to pump hard to achieve this thing. So 1064 is the most feasible lasing output which we achieve in a 4-level YAG lasing system. So हमने यहाँ पे ये देखा कि YAG laser जो है वो 4-level laser, और इसके जो it has a cluster of जो है ना वो pump levels हैं, और ये pump की जा सकती है IR region में mostly, like as I mentioned, the krypton lamp जो है वो use की जाती है, और इसके अलावा इसमें इसकी लेजिंग ट्रांजिशन जो है वो मुख्तलिफ वेवलेंथ भी है, बट जो ज़्यादा सूटेबल है वो 1064 नैनोमीटर है. अगर हम 946 नैनोमीटर लेना चाहते हैं तो YAG को हम 3-level लेजर कंसीडर करेंगे. यू कैन सी हियर. ओके, दिस गैप इज वेरी स्मॉल. और जो लाइफ टाइम है, जहाँ पे जो पंप, जो क्लस्टर ऑफ पंप्स लेवल्स हैं, उनका जो लाइफ टाइम है वो अराउंड 100 नैनो सेकेंड है, और लाइफ टाइम ULL का है तकरीबन 1.2 मिली सेकेंड. और फ्रॉम LL टू ग्राउंड इट टेक्स यानी कि 30 nanosecond to decay to the ground and ready to pump and to achieve the population inversion. So the suitable wavelength जिसकी है 1064 nanometer. I'll move to the next slide. Yeah, so in this slide, what we see is a helium neon laser. Helium neon laser is also considered to be 4-level laser. And it's basically gas laser like helium and neon, both are inert gases, and it's filled in the gas tube, seal tube, okay, and discharge is produced here. This discharge is a pump source. This electrical discharge is a pump source here. So what exactly happens? The helium is excited, okay, and the resonant energy is transferred to the neon, and lasing is happening because of the neon. So what do you see here? Like this is energy in electron volt. Okay, so it's excited, and helium is excited, and helium transfer energy to the neon. And after that, you can see the laser output here. Okay, and this is radiative decay. It can be spontaneous or something like this, and then finally it goes to the ground state. So what exactly happening here, the pumping mechanism here, it involves the resonant energy level between helium and neons. Okay, so then the lower levels, so lower levels here reveals an intervening metastable state. Okay, so this is actually pump here, and this energy is transferred to the neon, and from here the lasing happens. It stays there, the population inversion achieved here, and then the laser happened here. And there are a number of wavelengths you can see here, like can be 730 nanometer, that is infrared, and red 632 nanometer, green 543 nanometer mostly, and most feasible one is 632.8 nanometer, what we achieve here. And so as usual, the population inversion achieved here. Okay, and then it decays to the other levels by emitting the laser light here. Here this decay is a rapid decay, which is it shows the 600 nanometer here, and it can be a spontaneous emission of the light. Okay, so this light you can see as a pink or yellow in the beginning when you turn on the laser. So you can see this because of this 600 nanometer is kind of pink and yellowish light in the beginning. So what I explained here actually कि हीलियम नियॉन लेजर जो है वो आपकी 4 लेवल लेजर है, ठीक है। इसमें डिस्चार्ज ट्यूब में हीलियम और नियॉन जो है वो फिल की जाती है। इसकी डिटेल we'll see in the later chapters. यहाँ पे थोड़ी सी इंट्रोडक्शन सी दी जा रही है लेजर्स के बारे में। So इलेक्ट्रिक डिस्चार्ज प्रोड्यूस किया जाता है जैसे पंप सोर्स है। So pumping होती है जो रेजोनेंट एनर्जी जो है हीलियम को ट्रांसफर करते हैं नियॉन को। ओके, फॉर नियॉन सो जो लेजिंग होती है वो नियॉन की वजह से होती है। मोस्ट सूटेबल जो इसकी जो वेवलेंथ है वो 632.8 नैनोमीटर है। इट्स रेड range. Other lasing transition also possible, but under certain circumstances. So, but mostly commonly used 632.8 nanometer, and this is जो इसका ज़्यादातर वो यूज़ की जाती है, वो यही यूज़ की जाती है। उसके बाद रेडिएटिव डिके होता है। रेडिएटिव डिके स्पॉन्टेनियस एमिशन है। स्पॉन्टेनियस एमिशन शुरू में जब आप ऑन करते हैं लेजर को तो आपको हल्का हल्का पिंक कलर सा नजर आता है। दैट इज बिकॉज ऑफ द रेडिएटिव डिके अराउंड 600 नैनोमीटर की रेंज में होता है। नाउ लेट्स मूव टू द नेक्स्ट स्लाइड। Next slide actually is copper vapor laser. So copper vapor laser, I mean its energy diagram is a bit different than the other lasers. Okay, so it's a 3-level laser as you can see here, but here this is ULL, upper lasing level, lower lasing level, ground, but there is no pump level here. So the ULL is served as a pump level as well. Okay, so this is unique characteristics of this copper vapor laser. Copper and vapors. So copper, vaporize the copper and filled in a tube. Okay, so it has a 3-level laser. Okay, and it resembles 4-level laser system. Okay, because in 4-level laser system we have ULL and LLL. Okay, so in 3-level laser system, actually we don't have LL, low lasing level. Okay, ULL, pump level and ground. But here in this case, this is 3-level laser, but it like a 4-level laser, because ULL and LL levels are there. Okay, so there is no pump level. So in this system, what exactly happens? Energy is directly injected into the upper lasing level, because there is no pump level. So that is why energy is directly injected to the upper lasing level. Okay, by the collision of electron with the copper atoms. Okay, so what exactly happened? The energy is injected to the upper lasing level, and this energy is generated because of the collision of electron with the copper atoms. The collision of electrons with the copper atoms. Okay, so definitely it's not true 3-level system, and it has LLM. In normal or usual 3-level system, there is no low lasing level. So it resembles to 4-level laser, but this is 3-level laser. There is no pump level here. So energy is directly injected to the ULL, upper lasing level, and it does not operate in a CW mode. Okay, what is the meaning? It doesn't operate CW mode. All the 3-level lasers, if you remember, as I mentioned, that it's hard to pump continuously. Okay, so that is why this is also 3-level laser, even though it resembles to the 4-level lasing system, but it has 3 levels. So that is why it's hard to pump. Okay, so it is only operated in pulse mode. Okay, and it doesn't operate in a CW mode because the lifetime of UL is shorter than the LLM. Okay, so usually in 4-level laser systems, the ULL lifetime is longer, but here the thing is that the ULL lifetime is shorter than LLM. So lasing from here, it immediately decay to LLM, and lasing happen here, like 510.5 nanometer, 578.2 nanometers. But in here, what do you see? That first thing, energy directly injected to ULL, and it immediately, in a short time, it decays to LLM, and it the lasing emission happen between ULL and LLM. You can see 510.5 nanometer and 578.2 nanometers. So the lifetime of ULL is shorter than that of LLM. Okay, so this is one of the reasons it cannot be operated in CW mode. It has to be in a pulse mode. So laser, it goes to the ground and then it pumped again and then it come back. So इस स्लाइड में मैंने क्या एक्सप्लेन किया है? कॉपर वेपर लेजर. ओके, कॉपर के वेपर्स को एक डिस्चार्ज ट्यूब में जो रखा जाता है, ठीक है, और इसके अंदर जो इलेक्ट्रॉन की कोलिजन होती है कॉपर एटम के साथ, तो वो इलेक्ट्रॉन की कोलिजन जो होती है वो कॉपर एटम के साथ, उससे एनर्जी जनरेट होती है, और ये एनर्जी जो है ना वो डायरेक्टली जो है ना वो अपर लेजिंग लेवल, बिकॉज यहाँ पंप लेवल नहीं है, अपर लेजिंग लेवल की जाती है, और अपर लेजिंग लेवल से वो लो लेजिंग लेवल पे जब डिके करता है जो एटम, तो लेजिंग होती है. ठीक है, ये 3-लेवल लेजर सिस्टम है, रिसेंबल टू 4-लेवल है, क्योंकि इसमें ULL और RLL है, पंप लेवल इसमें मिसिंग है, और आम जो नॉर्मल 3-लेवल लेजर है उसमें LLL, लोअर लेजिंग लेवल नहीं होता. सो दिस इज द डिफरेंस हियर. और ये CW मोड में अप्लाई ऑपरेट होती है, नहीं होती, सॉरी, CW मोड में ये ऑपरेट नहीं होती, और क्योंकि जो लाइफ टाइम है आपका ULL इज लेस देन LLL, सो वो रैपिड डिके होता है यहाँ से. So I hope you understand, and some more I will continue this chapter in my next lecture.